The hedgerow exploded upward in a fountain of ancient earth and splintered roots. For exactly 4.7 seconds, timed by 3 separate officers with stopwatches, a modified Sherman tank disappeared into a cloud of torn vegetation and centuries-old soil. Then it emerged on the far side, trailing broken oak branches like battle flags, its hull level, its crew alive, its vulnerable belly armour never once exposed to the German Panzerfaust teams waiting in the next field. Lieutenant General Omar Bradley uncrossed his arms. Around him, a cluster of ordnance specialists and corps commanders stood in stunned silence. They had watched American boys die by the thousands trying to breach these Norman field boundaries. They had seen Sherman tanks tilt backward at suicidal angles, exposing their 1-inch belly plates to German rockets that could penetrate 6 inches of steel. They had calculated that at current casualty rates, the entire First Army would be bled white before reaching the base of the Cotentin Peninsula. And now, 3 miles southwest of Street. Lo, on this July afternoon in 1944, they had just watched a device so simple that Bradley had initially dismissed the report when it first crossed his desk. 4 steel prongs jutting forward like tusks. Nothing more. No advanced engineering, no exotic materials, no sophisticated technology. Just salvaged German beach obstacles welded to a tank's front hull by a sergeant who had learned his craft not in any military academy, but in the hard school of Depression-era New Jersey, where you fixed things yourself, or they stayed broken. I want these devices manufactured and fitted to every tank we can modify, Bradley said quietly. Every Sherman, every Stuart, every tank destroyer, round-the-clock production. Use every ordnance unit, every maintenance depot, every welder we have. I want them ready before Operation Cobra launches. The words hung in the summer air for a moment. Then ordnance officers scattered to their vehicles, already calculating production schedules, steel requirements, welding capacity. 11 days. They had 11 days to transform a single sergeant's improvisation into a force-wide capability that might break the deadliest stalemate American arms had faced since the trenches of the First World War. Because the problem was not German concrete fortifications. It was not minefields or machine gun nests or the vaunted Atlantic Wall that Nazi propaganda had declared impregnable. The problem was far older and far more intractable than anything German military engineers had constructed. The problem was the Bocage itself, a medieval landscape of earthen ramparts and interwoven vegetation that had been growing, compacting, and reinforcing itself for 1,000 years. And for 6 weeks, it had been killing Americans faster than the replacement system could fill the gaps in shattered rifle companies. The hedgerows of Normandy were not hedges in any sense that American soldiers understood. They were not the decorative shrub borders of suburban lawns back home, not agricultural fencing that could be cut or pushed aside. They were fortifications that medieval Norman farmers had begun building in the Dark Ages by clearing stones from their fields and piling them along property boundaries. Generation after generation had added more stones, more earth. Seeds had fallen and taken root. Oak trees, hawthorn, brambles, and wild roses had sprouted and intertwined. Over centuries, the walls had grown into earthen banks 3 to 12 feet high and 1 to 10 feet thick at the base. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed because tomorrow I've saved something extra special for you. The soil composing these banks was packed harder than concrete, compacted by centuries of settling and reinforced by root systems that penetrated 10 to 15 feet deep through the earthen mass. On top of these ramparts grew vegetation that rose another 15 feet, ancient oaks with trunks 5 inches in diameter, thorns that could tear cloth and flesh, branches so densely interwoven that they formed nearly solid barriers. The roots binding everything together were so thoroughly enmeshed after a millennium of growth that the hedgerows could not be dug through without power tools and could not be blown apart without massive explosive charges that announced American intentions to every German within 2 miles. These hedgerows surrounded irregular fields that averaged 200 to 400 yards across. Some fields were nearly square, others long and narrow, others triangular, the chaotic product of 1,000 years of inheritance law and land division. Aerial reconnaissance photographs taken before D-Day had revealed the true scope of the nightmare. One 8-square-mile section near Street Low contained nearly 4,000 separate hedge-enclosed fields. Each field was a FAFO, potential fortress. Each hedgerow formed a defensive wall, and there were thousands of them stretching across the entire American sector, from the coast to the interior. For German defenders, the Bocage was a gift from history. Every hedgerow was a ready-made defensive position superior to anything military engineers could construct. Machine gun teams could dig firing positions into the earthen banks, creating small apertures just large enough for a barrel positions invisible from more than a few yards away, protected from artillery by the earthen mass itself, immune to everything except a direct hit by large-caliber shells. The vegetation on top provided perfect concealment from aerial observation. Spotter planes flying overhead saw only an unbroken canopy of green. A single German squad, 8 or 9 men with a machine gun and rifles, could cover an entire field and hold off an American company of 200 men for hours. The Germans did not need continuous defensive lines. They simply positioned small groups throughout the Bocage, creating a defense in depth, where each position supported the others through interlocking fields of fire. For American attackers, every field crossing was a journey into pre-targeted killing zones. There was no cover in the middle of a Norman field, no trees, no rocks, no depressions in the ground. Just open grass or crops with German MG 42 seconds covering every square yard from positions that could not be seen until they opened fire. The Germans had already registered their weapons on likely crossing points, marking ranges, calculating angles. The instant American troops emerged from one hedgerow, German gunners simply fired at predetermined points and hit whatever was there. The sunken lanes connecting the fields were equally deadly, narrow passages worn deep into the earth by centuries of cart traffic, barely wide enough for a single vehicle. These were obvious routes for American advance and therefore obvious places for German ambush. The Germans would block the lanes with felled trees or rubble, then position machine guns to cover the obstacles from concealment. American troops attempting to clear these lanes were channeled into narrow defiles where a single gun could stop an entire platoon. And American tanks, the Sherman medium tanks that were supposed to be the key to mobile warfare and rapid exploitation, were neutralized completely. The Sherman was a good tank by any reasonable standard. Its 75mm gun could destroy any German tank at normal combat ranges. It was reliable, easy to maintain, and produced in quantities German industry could not match. American factories were building Shermans at more than 1,000 per month, but none of that mattered in the Bocage, because Sherman tanks could not penetrate the hedgerows. The earthen banks were too thick, too solid, too heavily reinforced by root systems. A Sherman's main gun could blow a hole in the vegetation on top, but that did not create a breach, large enough for the tank to pass through. The earthen base remained intact. Desperate tank commanders began attempting to breach obstacles by brute force. They would back up to get a running start, then accelerate directly at the hedgerow, attempting to use the tank's weight and power to smash through or climb over. This tactic was suicidal. When a Sherman attempted to ride up and over a hedgerow, the front of the tank would rise as it climbed the earthen bank, tilting backward at angles of 30 to 40 degrees. This exposed the belly of the tank, the underside between the tracks, protected by only 1 inch of steel armor designed merely to resist mine fragments, not to stop anti-tank weapons. A German soldier with a Panzerfaust, the shoulder-fired anti-tank rocket issued to German infantry by the thousands, could position himself in the next field and simply wait. He would hear the tank engine roaring as the Sherman climbed the hedgerow. He would see the front of the tank rise, above the vegetation. And when the belly armor was exposed, he would fire. 1 rocket was usually sufficient. The Panzerfaust could penetrate nearly 6 inches of armor. Against the Sherman's 1-inch belly plate, it was devastatingly effective. Lieutenant Colonel Wesley Yale, commanding a tank battalion in the 2nd Armoured Division, lost 4 Sherman tanks in a single morning attempting to breach hedgerows near the town of Isigny. 4 tanks destroyed, 4 crews killed or wounded, 16 men dead or injured, and not a single successful breach. His after-action report, filed on June 15th, captured the frustration felt by every American armour officer in Normandy. The enemy need not even see our tanks to destroy them. They position themselves in the next field behind the next hedgerow and simply wait. They listen for the sound of our engines. They hear us climbing the obstacle, and when we reach the top, when our belly is exposed, they fire. We are losing crews and machines to an enemy we never see, never engage, never have a chance to fight. Our tanks, which should be our greatest advantage, have become death traps in this cursed country. American forces tried every solution their training and doctrine suggested. Combat engineers were brought forward to blow gaps in the hedgerows using explosives. This technique worked technically. A properly placed charge could blast a hole large enough for a Sherman to pass through. But the tactic had fatal flaws. First, it was slow. Engineers had to move forward under fire, approach the hedgerow, place charges, connect detonators, retreat to safety, and blow the charge. This process took 10 to 15 minutes under ideal conditions, longer under fire. Second, the explosions announced American intentions to every German within hearing. Enemy machine gunners and mortar teams would train their weapons on the gap before the smoke cleared. Third, American infantry and tanks advancing through these blown breaches were funneled into a single, narrow opening that became a pre-targeted killing zone. Specialized bulldozer tanks proved little better. These were standard Shermans fitted with heavy steel bulldozer blades designed originally for clearing beach obstacles. In theory, they could push through or scrape aside the hedgerows. In practice, they became priority targets for German anti-tank gunners. The bulldozer tanks were slower than standard Shermans, less maneuverable, and highly conspicuous. German observers would identify them immediately and direct anti-tank fire at them, knowing that destroying the bulldozers would deny the Americans their primary means of breaching obstacles. By late June 1944, 6 weeks after D-Day, the American advance had slowed to a nightmarish crawl measured not in miles per day but in yards per hour. Official U.S. Army histories document that 8 Corps, advancing through the Bocage toward La Haye-du-Puits, suffered over 10,000 casualties while advancing approximately 7 miles. The 1st Infantry Division, which had landed on Omaha Beach on D-Day, lost 75% of its frontline infantry in the first month of combat. Companies that had landed with 150 men were down to 30 or 40 effectives. This was not mobile warfare. This was not the rapid exploitation that Allied planners had envisioned. This was attritional combat where every field had to be fought for, every hedgerow assaulted, every few hundred yards of ground purchased with American blood. And America, for all its industrial might and manpower reserves, could not sustain these casualty rates indefinitely. General Bradley faced a crisis that threatened not just his personal reputation, but the entire strategic plan for the invasion of Europe. His forces were exhausted, demoralized, and bleeding irreplaceable infantrymen at rates that could not be sustained. The British and Canadian forces to the east, fighting around Caen, were making equally limited progress. The grand strategy that had guided 2 years of planning the vision of rapid breakout and mobile warfare across France was collapsing into the same kind of static trench warfare that had characterized the Western Front in World War I. Bradley's Chief of Staff, Major General Walter Bedell Smith, described the situation in blunt terms. In the south of Normandy, every small field is a fortress, every hedgerow a German strongpoint. We are fighting World War I again, but this time the trenches are green and growing. Our advantages in mobility, armour, and firepower are negated by terrain. The Germans are trading space for casualties, and they are winning that exchange. The psychological impact on American troops was severe and cumulative. Men who had survived the horrors of Omaha Beach, who had faced German machine guns and artillery during the landing, found the bocage even more terrifying. On the beach, at least the enemy was visible. You could see the German bunkers, identify targets, know where fire was coming from. In the hedgerows, death came unseen from positions that could not be located until they opened fire. Captain Joseph Ewing, serving with the 175th Infantry Regiment of the 29th Division, wrote after the war, "We advanced through a vast maze of natural fortifications, miles in depth. Every hedgerow was a possible enemy position. Every field crossing was potentially fatal. We could not see more than one field ahead. We had no way of knowing where the Germans were until they opened fire. The tension, the constant awareness that at any moment machine gun fire might erupt from invisible positions, wore men down faster than actual combat." Into this desperate situation, where the entire Normandy campaign teetered on the edge of failure, where American casualties mounted by the thousands and no solution seemed possible, came an ordinary soldier with an extraordinary idea. His name was Curtis Grubb Culin III, and he was about to prove that sometimes the best solutions to impossible problems come not from generals with decades of experience or engineers with advanced degrees, but from sergeants with welding torches and enough common sense to recognize a good idea when they heard one. Curtis Grubb Culin III was nobody special in the vast hierarchy of the American Army. At 29 years old, in the summer of 1944, he was a sergeant serving with the 102nd Cavalry Reconnaissance Squadron, part of the 102nd Cavalry Group operating under 5th Corps. He held no advanced degrees. He had no engineering training. His background was utterly ordinary, the kind of American biography repeated millions of times across the armed forces. Culin was from Cranford, New Jersey, a small town about 15 miles west of New York City. His father worked as a salesman for a liquor distributor. Curtis had attended local public schools, graduating from Cranford High School in 1935. Before the war, he had worked as a sales promotion assistant for Shenley Industries, the same company that employed his father. When war came, he enlisted in the New Jersey National Guard, was mobilized with his unit, and trained as a tanker and driver. What Curtis Culin had was something that could not be taught in any school or acquired through formal training. He had practical American ingenuity, the kind of problem-solving ability that came from growing up during the Great Depression, when money was scarce and you learned to fix things yourself, to make do with whatever materials were available, to improvise solutions rather than waiting for someone else to solve your problems. This was a particularly American trait, born of a culture that valued individual initiative and practical results over formal credentials and theoretical knowledge. It was the same spirit that had driven American inventors and innovators for generations, from Benjamin Franklin experimenting with electricity to the Wright brothers building an airplane in a bicycle shop. It was the belief that any problem could be solved if you thought about it clearly enough and were willing to get your hands dirty. In early July 1944, during a brief respite from combat operations, soldiers from Culin's unit gathered in an informal group to discuss the hedgerow problem. This was not an official meeting or planning session. It was just soldiers talking, sharing frustrations, venting anger about their situation. Tank crews, infantry, and officers all contributed to the conversation. They talked about friends who had been killed or wounded. They talked about tanks that had been destroyed attempting to breach hedgerows. They shared ideas, most of them impractical or impossible, about how to solve the problem. At some point in this discussion, a soldier identified by military historian Max Hastings only as a Tennessee hillbilly named Roberts made a suggestion that sounded to most of the group like a joke, or perhaps the ramblings of a man driven half mad by combat stress. According to Hastings, this soldier said something like, "Why don't we get some saw teeth and put them on the front of the tank and cut through these hedges?" Most of the soldiers listening laughed or dismissed the idea immediately. It sounded ridiculous. Saw teeth on a tank, like some kind of cartoon monster. But Curtis Culin, sitting quietly in the group, did not laugh. He heard something in the suggestion that others missed. He recognized that beneath the crude phrasing was a mechanically sound principle. If tanks could not climb over hedgerows without exposing their vulnerable undersides, and if they could not punch through the solid earthen banks by brute force, then perhaps they could cut through them. Use the tank's own weight and power to drive steel blades through the base of the hedgerow, severing roots and penetrating earth like a plough cutting through tough soil. Culin began thinking about the problem systematically. He envisioned a set of steel prongs or tusks projecting forward from the tank's hull. These prongs would need to be angled slightly downward so that when the tank drove into a hedgerow, they would bite into the earthen bank at ground level rather than riding up the face of the obstacle. As the tank continued forward with full engine power, the prongs would cut through the roots and earth while the tank's weight kept it level and prevented the dangerous upward tilt that exposed the belly armor. The concept was simple, elegant, and achievable with available technology, but it required the right materials. The prongs needed to be strong enough to penetrate centuries of packed earth and dense root systems. They needed to be heavy enough to hold their position under stress, but not so heavy that they overloaded the tank suspension or reduced mobility. They needed to be made from high-quality steel that would not bend or break under the enormous forces involved in cutting through a hedgerow. Where could such materials be found in Normandy in July 1944? The answer was literally lying on the beaches where the invasion had taken place 6 weeks earlier. Before D-Day, German engineers had installed thousands of obstacles along the Normandy coast, creating a barrier system designed to destroy Allied landing craft before they could reach shore. Among the most common obstacles were devices called Czech hedgehogs, named for their resemblance to anti-tank obstacles the Czech army had developed before the war. Each hedgehog was constructed from 3 steel I-beams industrial-grade structural steel, about 6 feet long, welded together at angles to form a 6-pointed obstacle that looked somewhat like a giant jack from a children's game. These hedgehogs were supposed to rip open the hulls of landing craft or provide anchor points for mines. In the event, the invasion had bypassed or destroyed most of them. Thousands of Czech hedgehogs now lay scattered along the invasion beaches, having failed to stop the Allied assault. They had been pushed aside by landing forces, blown up by combat engineers, or simply bypassed. The steel beams, still intact and of excellent quality, were being collected in salvage yards behind the beaches, waiting to be shipped back to England for recycling. Here was exactly what Culin needed: high-quality structural steel, already cut to convenient lengths, available in unlimited quantities. All he needed was permission to experiment and access to welding equipment. Getting approval from his immediate superiors proved surprisingly easy. Officers at every level of the American army in Normandy were desperate for any solution to the hedgerow problem. When Curtis Culin approached his company commander with rough sketches and an explanation of his concept, including where he planned to source materials, the captain gave immediate approval. Within 48 hours, Culin had been given access to a Sherman tank for experiments, welding equipment from the unit maintenance section, and authorization to organize a work party to retrieve steel beams from a salvage yard near Omaha Beach. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, it means a lot to us. Now, back to the story. The prototype took 3 days to construct in early July 1944. Culin and his work party selected 4 sections of steel I-beam from the salvage yard, each approximately 5 feet long and weighing about 100 pounds. They used cutting torches to bevel the forward ends of the beams, creating angled cutting edges that would bite into earth and roots more effectively than blunt ends. They welded a horizontal crossbar to hold the 4 prongs in position, spacing them evenly across the width of the tank's front hull. Then they welded the entire assembly prongs and crossbar together to the lower front armor plate of the Sherman, positioning it so the prongs projected forward and angled slightly downward. The result was crude but functional. 4 steel tusks projecting forward from the tank's hull, angled downward at perhaps 10 degrees from horizontal, ready to be driven into a hedgerow. The assembly added about 400 pounds to the tank's weight, not enough to significantly affect performance, but enough to be noticeable. The prongs extended about 4 feet in front of the tank's normal profile, which meant drivers would need to be careful in close-quarters maneuvers. But if the device worked, these minor inconveniences would be more than justified. The first test was conducted on July 11th, 1944, in a field near the town of Isigny-sur-Mer, several miles inland from Omaha Beach. A small group of perhaps 20 soldiers gathered to watch mostly tankers and officers from Culin's unit. Most of them expected another failure. They had seen too many proposed solutions to the hedgerow problem, all of which had failed in one way or another. A tank with steel prongs welded to the front seemed unlikely to succeed where explosives and bulldozers had failed. The test hedgerow was selected carefully. It needed to be representative of typical Norman bocage, not an unusually small or weak example that might give false results. The hedgerow they chose was about 4 feet high at the earthen base, topped with 15 feet of mature vegetation, including oak trees with trunks 4 or 5 inches in diameter. This was an average hedgerow, the kind American tankers encountered dozens of times every day. The Sherman tank backed up to give itself room to build speed. The driver, a corporal from Pennsylvania, whose name has not been preserved in historical records, was understandably nervous. If the device failed, if the tank bellied up on the hedgerow as so many tanks had before, he and his crew might be the next casualties of the Bocage. But he trusted Sergeant Culin, who had explained the theory carefully and seemed confident it would work. The driver shifted into gear, advanced the throttle, and aimed directly at the hedgerow. 5 miles per hour. 8, 10. The tank hit the hedgerow with the prongs leading. There was a sound like heavy canvas, tearing a deep ripping noise as steel cut through earth and roots. The prongs bit into the earthen bank and penetrated deep. For a moment, it seemed the tank might stall, might be stopped by the resistance of the obstacle. Then the engine roar increased. The driver gave it full throttle. The tank's treads gripped the ground and pushed forward. Earth fountained up and over the tank's hull, blown upward by the force of the breach. Branches snapped, tree trunks splintered. Vegetation showered down on the turret and rear deck. And then, less than 5 seconds after impact, the Sherman burst through to the other side of the hedgerow, trailing broken branches and torn roots, but otherwise completely undamaged. The tank had not climbed the obstacle. It had cut through at ground level, exactly as Culin had predicted. The watching soldiers erupted in cheers and shouts. Some of them were crying not from sadness but from relief and hope. For 6 weeks they had watched friends die in futile attempts to breach these obstacles. For 6 weeks they had felt helpless against terrain that seemed unconquerable. Now, suddenly, impossibly, a simple device made from scrap metal had solved the problem. The tankers surrounded Culin, shaking his hand, pounding his back, thanking him with a fervour that embarrassed the modest sergeant. Officers who had witnessed the test were already calculating implications. If this worked once, it could work again. If one tank could be modified, all tanks could be modified. If the device was as simple and quick to manufacture as it appeared, then perhaps the entire American armor force could be equipped before the planned offensive. But a single successful test, however dramatic, was not enough to transform the course of a military campaign. The device needed to prove itself in repeated trials under various conditions. More tests were conducted over the next 2 days. Different hedgerows, different angles of approach, different speeds. Every test succeeded. The device worked reliably, predictably, safely. Tank crews quickly learned the optimal technique. Approach at 10 to 12 miles per hour, aim directly at the hedgerow, not at an angle. Give full throttle at impact. The tank would shudder as the prongs bit into earth, but it would drive straight through without climbing or exposing its belly. Breaching time averaged 5 to 8 seconds from impact to emergence on the far side. Word of Culin's invention spread rapidly through the 2nd Armoured Division and beyond. Within 3 days of the first successful test, Major General Edward Brooks, commanding the 2nd Armoured Division, had seen reports and requested a formal demonstration. Brooks was a competent, aggressive commander who understood armour tactics and recognized a breakthrough when he saw one. He immediately grasped the significance of Culin's device and understood that it needed to be demonstrated to the one man whose approval and support could authorize mass production and force-wide implementation. On July 13th, General Brooks sent a message to 1st Army Headquarters requesting that Lieutenant General Omar Bradley visit the 2nd Armoured Division area for a demonstration of a new hedgerow breaching device. Bradley, buried under reports and complaints about the stalled offensive, was initially skeptical. He had seen proposed solutions before, all of which had failed. But Brooks insisted this was different, and Bradley trusted his division commanders. He agreed to visit the following day, July 14th, 1944. The demonstration that would transform the Normandy campaign took less than 5 minutes. Bradley arrived with his entourage, Major General Leonard Guerreau of 5th Corps, and several ordnance specialists to a field 3 miles southwest of Street Low. 2 tanks had been prepared for demonstration, a light M5A1 Stuart tank and a medium Sherman, both equipped with Culin's device. The hedgerow selected for the demonstration was carefully chosen to be representative of typical bocage terrain. A 5-foot earthen bank topped with thick brush and mature trees, the kind of obstacle that had stopped American advances for 6 weeks. Bradley and his officers took up positions where they could observe clearly without being in danger if something went wrong. The light tank performed first, backing up to gain speed, then accelerating directly at the hedgerow. The impact. The sound of tearing earth and breaking roots. The fountain of dirt exploding upward. And then the tank bursting through in less than 5 seconds. Before anyone could react, the Sherman demonstrated the same capability with even more dramatic effect. Its greater weight and power drove through the obstacle like it was soft clay rather than centuries-old earthen wall reinforced with tree roots. Bradley stood silent for a moment, his mind racing through implications. 6 weeks of stalemate, thousands of casualties. An offensive about to be launched that might fail if tanks could not maneuver through the bocage. And here, demonstrated twice in the space of 2 minutes, was the solution. Simple, reliable, achievable with available materials. He turned to Lieutenant Colonel John Medaris, 1st Army Ordnance Officer, and issued the orders that would change everything. I want these devices manufactured and fitted to as many tanks as possible. Every Sherman, every Stuart, every tank destroyer we can modify. I want them ready before Operation Cobra launches. Round-the-clock production. Use every ordnance unit, every maintenance depot, every welder we have. This is top priority. The conversation that followed lasted less than 10 minutes, but set in motion a manufacturing effort unprecedented in its speed and scale. Bradley wanted these devices on as many tanks as possible before Operation Cobra launched. The offensive was scheduled to begin in 11 days on July 25th. That meant 11 days to manufacture hundreds of devices, transport them to units scattered across Normandy, and weld them onto tanks. Medaris was a West Point graduate, class of 1930, a professional officer with extensive experience in logistics and materiel. He understood immediately that this was not a routine production job. This was an emergency crash program that might determine the outcome of the entire Normandy campaign. Medaris returned to his headquarters and within hours had issued orders that would set in motion the most rapid military production program of the war. Every ordnance company, maintenance battalion, and repair depot in the American sector received orders on July 14th to begin immediate production of hedgerow cutting devices. Specifications were transmitted by telephone and radio. 4 steel prongs, approximately 5 feet long, made from German beach obstacle steel, beveled cutting edges on the forward ends, crossbar to hold prongs in position, entire assembly welded to lower front hull of tank, simple enough that any competent welder could fabricate it. complex enough that it required skill and care to ensure the welds would hold under combat stress. The raw material was abundant. Salvage yards behind the beaches contained thousands of tons of steel from destroyed German obstacles. Trucks began hauling steel beams to ordnance units across Normandy. The beams arrived in bundles, still covered with rust and barnacles from their time under water, some still showing damage from explosives or shellfire. Ordnance troops would sort through the beams, selecting those that were straight and undamaged, rejecting any that showed cracks or severe corrosion. The selected beams would be cut to length using acetylene torches, beveled on the ends, and set aside for welding. The welding work was brutal. Summer heat in Normandy in July 1944 reached into the 80s and 90s Fahrenheit. Welders worked in heavy leather protective gear, wearing face shields and gloves, manipulating steel beams that weighed over 100 pounds each. The work was done outdoors or in canvas-sheltered areas because there was no time to set up proper workshops. Each device required multiple hours of welding. The 4 prongs had to be welded to the crossbar. The crossbar had to be welded to the tank's hull. Every weld had to be strong enough to withstand the enormous forces generated when the tank drove into a hedgerow at full speed. A weak weld could fail at the moment of impact, potentially causing the tank to belly up on the obstacle exactly as unmodified tanks did. The ordnance units worked in shifts, 24 hours a day. Welders worked 6-hour shifts, then rested while other crews took over. Acetylene tanks and welding rods had to be trucked in constantly to keep the work going. When one ordnance company ran low on materials, trucks would be dispatched to transfer supplies from units that had excess. The entire system operated with the kind of flexible improvisation that characterized American military logistics at its best. There were no detailed plans, no carefully calculated production schedules. There was only the urgent need to produce as many devices as possible before Operation Cobra launched. Tank crews from combat units would drive their vehicles to the nearest ordnance facility, wait while the device was fabricated and installed, then drive back to their units. Some crews waited 6 or 8 hours. Others waited overnight. But they waited because they knew the device might save their lives. Tankers who had lost friends to Panzerfaust fire when tanks bellied up on hedgerows understood that Culin's device could prevent those deaths. The modified tanks began appearing in combat units in mid-July. At first, there were just a handful per battalion. Crews with modified tanks would volunteer for the most dangerous missions, testing the devices under actual combat conditions. The reports that came back were uniformly positive. The devices worked exactly as demonstrated. Tanks could breach hedgerows in seconds without exposing their vulnerable undersides. Tank commanders could choose their own routes through the Bocage rather than being forced to follow roads or search for gaps that might be covered by German fire. The tactical flexibility was transformative. By July 20th, 5 days before Operation Cobra was scheduled to begin, approximately 300 tanks in First Army had been fitted with Culin's device. This represented about 15% of American armor in theater. It was not enough. Bradley wanted more. Medaris pushed production harder. More ordnance units were diverted from other tasks. More welders were pulled from maintenance work and set to manufacturing hedgerow cutters. By July 24th, the day before Operation Cobra launched, approximately 500 devices had been manufactured and installed on American tanks. This represented nearly 60% of the Sherman medium tanks, Stuart light tanks, and M10 tank destroyers that would participate in the offensive. It was not 100%, there had not been enough time, but it was enough to give American armor the mobility it needed, enough to restore tactical flexibility, enough to break the stalemate. The tanks themselves looked fearsome with their new equipment. The 4 steel prongs projecting from each hull gave the Shermans an aggressive, almost predatory appearance. Soldiers began calling them rhino tanks, drawing the obvious comparison to the horned animals of Africa. The name stuck. Within days, everyone in the American Army knew what a rhino tank was. Operation Cobra launched on July 25th, 1,944, with the most concentrated aerial bombardment ever employed in support of ground operations. More than 1,500 B-17 Flying Fortress and B-24 Liberator heavy bombers, followed by approximately 1,000 medium bombers and fighter bombers, dropped over 3,300 tons of high explosives and 60,000 incendiary bombs on German positions northwest of Street Low. The bombardment was devastating. German defences were shattered. The Panzer Division, one of the elite German armoured formations defending the sector, was reduced to a remnant. Its commander, General Fritz Bayerlein, later described observing a huge dust cloud with fountains of earth spewing high in the air. My front lines looked like a landscape on the moon, and at least 70% of my troops were out of action dead, wounded, crazed, or numb. Into this chaos, American ground forces advanced. The Sevii Corps, commanded by Major General J. Lawton Collins's Lightning Joe, formed the main thrust. 3 infantry divisions led the assault, supported by 2 armoured divisions, the 2nd Armoured Hell on Wheels and the 3rd Armoured Spearhead. And a substantial portion of their Sherman tanks, approximately 60%, were now equipped with Curtis Cullin's Hedgerow cutting devices. The initial advance on July 25th penetrated approximately 1 mile slower than hoped, evidence that even the massive bombardment had not completely eliminated German resistance. But Major General Collins, monitoring the advance from his forward command post, recognized something critical. The German resistance, though still deadly, was not coherent. There was no defensive plan being executed, no coordinated counterattacks. The German command structure had been destroyed. Late in the afternoon of July 25th, Collins made the bold decision that would transform Operation Cobra from a limited offensive into a breakthrough. He ordered his 2 armoured divisions to begin their exploitation immediately, ahead of schedule. The plan had called for infantry to open a wide corridor first, but Collins saw that waiting might allow Germans time to recover. He decided to commit his armour while the Germans were still reeling. The armoured exploitation began at dawn on July 26th. Combat Command A of the 2nd Armoured Division, led by Brigadier General Maurice Rose, drove south from the Street Low area with orders to advance as far and as fast as possible. And for the first time since D-Day, American armour operated with true mobility and freedom of manoeuvre in the Norman Bocage. The Rhino tanks crashed through hedgerow after hedgerow, choosing their own routes, avoiding German strongpoints, exploiting gaps in the disintegrated German defence. Tank commanders no longer needed to follow roads where anti-tank guns might be positioned. They no longer needed to search for gaps in hedgerows that might be covered by German fire. They simply drove cross-country, breaching obstacles at will, maintaining momentum, preventing Germans from establishing new defensive positions. The psychological impact on German forces was catastrophic. For 6 weeks, German defenders had relied on the Bocage as their primary defensive advantage. They had used the hedgerows to channel American attacks into predetermined killing zones. Now, suddenly, impossibly, American tanks were appearing from unexpected directions, breaking through hedgerows that Germans had assumed were impassable barriers. By midday on July 26th, lead elements of the 2nd Armoured Division had advanced 6 miles beyond the start line. 6 miles in half a day farther than the entire First Army had managed to advance in the previous 2 weeks of grinding attritional combat. A senior German NCO, identified in captured documents only by his last name Klene, wrote in his diary on the evening of July 26th. Today, we understood that everything is lost. The Americans have broken through. Their tanks are everywhere. They come from directions we thought impossible. Our defensive positions that held for weeks are suddenly worthless. The men are talking among themselves in ways that would have been unthinkable a week ago. They speak of survival, not victory. July 27th, the American advance accelerated. The 30th Infantry Division reported in words that would become famous. This thing has busted wide open. The 3rd Armoured Division reached Coutances, a critical road junction approximately 15 miles behind what had been the German front line just 2 days earlier. German forces attempting to withdraw found their routes blocked by American armor that had already penetrated deep into their rear areas. By July 28th, the breakthrough exceeded even Bradley's optimistic projections. American forces had penetrated more than 20 miles beyond the start line in just 3 days. The German 7th Army, which had fought Americans to a standstill for 6 weeks, was in full retreat, its units scattered and disorganized, its ability to conduct coordinated defense destroyed. Post-battle analysis revealed the decisive role of the Rhino tanks. Staff officers examined after-action reports, interviewed unit commanders, and compiled statistics. The conclusion was clear. Approximately 70% of successful hedgerow breaches during Operation Cobra were accomplished by tanks equipped with Culin's devices. The remaining 30% required engineer support with explosives significantly slower and more vulnerable to German fire. Tank crews reported that Culin devices allowed them to breach typical Norman hedgerows in less than 10 seconds. This speed was absolutely critical to maintaining momentum. Previous methods had required 10 minutes to half an hour, allowing Germans to prepare defensive fire. The speed advantage provided by Rhino tanks gave American forces the tactical surprise and tempo that made rapid exploitation possible. Rhino tanks also suffered significantly fewer casualties than unmodified tanks. Ordnance officers analyzing loss rates found that Rhino tanks experienced approximately 40% fewer tank kills in Bocage terrain. The reason was simple. Modified tanks did not expose their vulnerable belly armor when crossing hedgerows, eliminating the single most common cause of tank losses. The strategic impact was immediate and far-reaching. By July 31st, just 6 days after the offensive began, 8 Corps captured Avranches, the gateway to Brittany and southern Normandy. The capture opened routes south and east. The entire Normandy front, static for 6 weeks, suddenly collapsed. On August 1st, 1944, the 3rd United States Army was officially activated under Lieutenant General George S. Patton, Jr. 3rd Army's mission was to exploit the breakthrough racing south into Brittany and east toward the Seine. Patton's forces advanced with astonishing speed, sometimes covering 50 miles in a single day. The liberation of Paris followed on August 25th, just 1 month after Operation Cobra began. The encirclement and destruction of German forces in the Falaise pocket in mid-August trapped between 50 and 100,000 German soldiers and destroyed the combat effectiveness of entire divisions. The Wehrmacht in France never recovered from this catastrophic defeat. For Curtis Culin, recognition came in the form of military awards and media attention. General Bradley personally recommended Culin for the Legion of Merit, praising his contribution to Operation Cobra's success and noting that his invention had saved countless American lives by restoring tactical mobility at a critical moment. Newspapers in the United States picked up the story. The Cranford Citizen and Chronicle published a feature article on September 7th, 1944, describing how a local sergeant had revolutionized warfare in Normandy. The story fit perfectly into the American narrative of citizen soldiers using practical ingenuity to overcome obstacles that defeated trained experts. But Curtis Culin himself, demonstrating the modesty that characterized him throughout his life, refused to take full credit. In interviews with commanders and journalists, he repeatedly attempted to give credit to the Tennessee soldier whose suggestion had sparked the initial idea, though, that man's identity remains lost to history. 4 months later, in November 1944, Curtis Culin's war ended in Germany's Hürtgen Forest during one of the longest and most brutal battles fought by American forces in Europe. On November 2nd, Sergeant Culin stepped on a German anti-personnel mine. The explosion shattered his left leg. Falling, he detonated a second mine that severely wounded his right thigh. Surgeons saved his life, but could not save his leg. The shattered limb was amputated. His combat service was over. Curtis Culin returned to the United States in 1945. He married, settled in New York City, and returned to work as a salesman for Schenley Industries. He raised a family. He lived quietly. He rarely spoke about his wartime experiences or his contribution to Allied victory in France. On January 10, 1961, outgoing President Dwight Eisenhower, who had been Supreme Commander of Allied forces in Europe, delivered remarks upon receiving the Hoover Medal Award. In that speech, Eisenhower chose to tell Curtis Culin's story as an example of American innovation and the importance of organizational systems that allow good ideas to rise from any level. There was a little sergeant, his name was Culin, and he had an idea, Eisenhower said. And his idea was that we could fasten knives, great big steel knives, in front of these tanks. And as they came along, they would cut off these banks right at ground level. This idea was brought to the captain, to the major, to the colonel, and it got high enough that somebody did something about it, and that was General Bradley, and he did it very quickly. Curtis Grubb Culin III died on November 20th, 1963, in Greenwich Village, Manhattan. He was 48 years old. He was buried with military honors in Fairview Cemetery in Westfield, New Jersey. A memorial plaque was later placed on a boulder outside the Cranford Municipal Building, commemorating his service and his contribution to Allied victory. The story of Curtis Culin is ultimately about what happens when ordinary people confront extraordinary challenges and refuse to accept that problems are unsolvable. It is about organizational cultures that value results over credentials and are willing to listen to ideas from any source. It is about the practical American tradition of hands-on problem solving, the belief that any problem can be solved if you think about it clearly enough and are willing to improvise with available materials. The steel prongs that Curtis Culin welded to a Sherman tank in July 1944 broke more than hedgerows. They broke a stalemate that threatened to turn the greatest amphibious invasion in history into bloody failure. They broke German confidence in their defensive strategy. They broke open the road from Normandy to Paris, from Paris to the Rhine, from the Rhine to Berlin. On that July afternoon, when Omar Bradley watched a Sherman crash through a hedgerow that had stopped American advances for 6 weeks, he witnessed a turning point as significant as any major battle. The solution was, as Bradley himself later wrote, absurdly simple, so simple that it had baffled an entire army for more than 5 weeks. But simplicity does not diminish importance. Often the best solutions are simple. Often the most effective weapons are not the most sophisticated, but merely the ones that solve the immediate problem. Sometimes a sergeant with a welding torch and an open mind accomplishes what generals and engineers with all their training and resources cannot. The Rhino tanks rolled through France in the summer and autumn of 1944, their steel prongs cutting through obstacles that had seemed impossible, restoring mobility to American armor, enabling the rapid exploitation that carried Allied armies from Normandy to Germany. They were crude devices, improvised from scrap metal by desperate men fighting a war that had to be won. They added nothing to the firepower of the tanks they equipped. They required no advanced technology, no exotic materials, no sophisticated manufacturing. They were simply steel prongs welded to the front of tanks, but they worked. And in war, that is all that matters.